Wow, your little skirt. So cute.
I don't know why it took one.
Who's with this? Jordan, was this yours? Or is this anyone's? Someone this class left it. No? Who's yours? Oh, it wasn't y'all. Uh-huh.
Mine are really like, yeah.
I don't even know what it's not.
I started laughing when I saw it.
What's tomorrow? To be like you.
All right. Y'all ready? So just a couple of quick things. So your quiz is on implicit differentiation. It's on Friday. Okay, remember that day class will be a little bit shorter. Then the other thing, normally I try not to tell you too far out because I don't want you to just fret about it. But you are gonna get for your quiz to work in a group of 2 or 3. Okay, so I don't need you to figure that out right now, but you will get to work in 3 or less. You cannot have a group of 4. If you have 4 friends that want to work together, you have to go 2 and 2. Yeah. So when you come in on Friday, you'll be in groups of 3. If you want to split off and be a 2, you can, but you can't have more than 3 in a group. Okay. All right. So we are going to learn 4 theorems today. Okay. And this might be a little boring, but hopefully they're not too hard. So if you'll start on intermediate value theorem. Okay, the theorem is written right here. We're going to kind of draw a little bit of stuff on your pink sheet, but then this pink sheet that you have, you get to use. It's kind of like your cheat sheet for theorems. So rather than us rewriting them, you're just going to do it on here. Okay. All right, so first one is intermediate value theorem. I want you to circle the conditions. Condition number 1 is you can only use intermediate value theorem on continuous functions. If it is not a continuous function, you cannot do intermediate value theorem. Okay, second thing is that the k that you want has to be between f of a and f of b. Okay, now I want you to put right above where the k is a y value. And so it has to be between the other 2 y values. F of a is a y value and f of b is also a y value. Okay, if that happens, here's your little whatever theorem. Okay, there must be an x value where x is between a and b so that f of c equals that. Okay. Now, I know that right now you're like, what the? So let's draw a picture. Okay, so give me a little graph here. Okay, like that. Here's what intermediate value theorem says. First thing is your graph has to be continuous. If it's not continuous, you can't use intermediate value theorem on it. Okay, if I picked 2 values, I'm going to call them A and B. So let's say that A is here. And let's say that B is over here. First thing I want you to do is find f of A and f of B. So f of A would be how tall this is. Okay, let's label that f of A. And f of B would be how tall the graph is over here. If you want to put a little dotted line here. Okay, so I find A and B are my x's, f of A and f of B are my y's. Okay, what this theorem says is that if I pick any number between these y values, I can promise you that there's an x where that Y value happened. Okay, so I want you to put a K value just somewhere here in the middle. We'll say this is your K value. Then what that means is that I could find somewhere between here and here that I hit that exact value. Okay, so in this case, if this is my K, then it would have happened right here. That's when it happens, and that would be your X equals C. Okay, so what I'm gonna have you do now that we have a picture is we're gonna write down your steps. Then we're gonna do an example off of your little white packet. So the first thing you check for IVT, okay, these are gonna be your steps over here to the side, is that your graph has to be continuous. Okay, if it is not continuous, you're done. Step number 2 is that you are going to find f of A and f of B. Remember, those are Y values, and they cannot equal each other. So I'm gonna find my first Y value, find my last Y value, and they can't come out to be the same. Here's why. Where is the Y value K supposed to be? It's supposed to be between them. And so if they come out the same, no number could ever be. So your third step is going to be the K that you want has to be between those values that you just found. Okay, the K value that you want has to be between f of A and f of B. If that happens, you can promise me that there's an X value that goes with that Y value. So I'm going to throw some little math symbols at you, okay, that we're going to use over and over again, but I'm also going to give you the option to write it in words if you like that better. Okay, put a little backwards E. X equals C within A to B. Such that f of C equals K. Okay. Once you've written it down in symbols, we're gonna write out what each of those weird symbols means. Okay, the little dot, 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 we already know what that means. Therefore, the backwards E means there must exist. So I'm gonna write on the bottom, therefore, there must exist an X equals C within. Okay, within is this kind of weird little thing, little E looking guy. Okay, within the interval from A to B, such that f of C is K. So the little backwards E is there must exist. The little weird thing here means within, and then ST means such that. Okay, now the good news for you is that your homework writes it out in words. Okay, but remember that if you're in this class, I'm assuming you may take a college calculus class, that those symbols are going to kind of come back. So I just want to kind of show them to you, but if you like writing it out better, I'm not going to require you to use those symbols. Okay, so let's do an example. This theorem makes tons of sense once you understand what it says. So take a look at number 1. Okay, number 1 says we have a little chart. If you look at it, okay, it has age and weight of a kid. So it says the table below shows the weight of an adolescent child measured in pounds as a function of time measured in years of age. Does intermediate value theorem guarantee that the child must have weighed exactly 40 pounds between 3 years old and 5 years old? Okay, let's follow our steps. Come over here to the side. Step number 1 is I need to know if it's a continuous quantity. When you gain weight, can you go from 100 pounds to 110 pounds in an instant? No. So weight is continuous. So I want you to write that down first. Okay, the first thing that I check is to make sure that I am dealing with a continuous quantity. So I'm gonna put weight is continuous, check. Step number 2 is that I'm gonna find the starting Y value and the ending Y value and make sure that they're not the same. Now, for our timeline here, we're working with 3 years old to 5 years old. So let's do the weight at 3 and then the weight at 5. And remember, my goal in this step is to make sure they can't be the same. So can you tell me from the chart, how much does baby boy weigh at 3 years old? 35 pounds. How much does he weigh at 5 years old? 42 pounds. Did they come out to be different numbers? Okay, then step number 3 is that the K value that I want, in this case, the weight that I want him to weigh, okay, has to be between those two numbers. Now, in this question, I want to guarantee that the child weighed 40 pounds. Is that between 35 and 42? Yes. Then you would say 40 pounds is between 35 and 42, therefore. Okay, IVT does guarantee that my baby can't go from 35 to 42 pounds if it doesn't hit 40 on the way up. Does that make sense? Just as a concept? Okay, so now you have the option of writing it in words or writing it in symbols. Okay, let's do it in symbols first. There must exist an X equals C within what timeline? Because remember, we're dealing with an X right now. Between which years? 3 and 5 years. Very good. Remember, these are X values. Such that the weight at that time is equal to 40 pounds. So there has to be a day between 3 and 5 years old that my weight on that day, C, is exactly 40 pounds. Kind of make sense? Okay, let's go down to part B. Same table, same baby, same weights. Does intermediate value theorem guarantee that the child must have weighed exactly 9 pounds between birth and 1 year old? Is weight still continuous? Yes. So I'm going to put weight is still continuous. Okay, check. Step number 2 is I want to find the starting weight and the ending weight on my interval, which is from 0 to 1. So what is baby's weight at 0? 10 pounds. What is the baby's weight at 1 year? 25 pounds. And remember, I want to make sure in this step that the numbers don't come out the same. So that in step 3, I can see if my number fits between them. Okay, what is the weight that I want the baby to weigh? 9. Does it fit in the middle? No, so I would say 9 pounds is not between my 10 and my 25. Therefore, IVT cannot guarantee this. Okay, not only can it not guarantee that value, but I really can't even use it in this situation at all. Okay, now, once you've written that down, I want you to read part C. So IVT does not guarantee that the baby's weight was ever 9 pounds. But part C, is it possible that the baby's weight dropped to 9 pounds between being born and then getting to 10 pounds? Would it be possible? Yes. Okay, babies lose weight all the time if they get sick, if they have trouble, whatever, eating. Okay, so is it possible? Yes, but IVT just doesn't guarantee it. IVT doesn't guarantee it, but it could have still happened. So when you do your homework, okay, and it's online, there's a drop-down menu that when IVT doesn't apply, there's gonna be an option that says IVT guarantees the baby never hit 9 pounds. That's not a thing. You can't promise it didn't happen. You can only say for sure it did, or maybe it did. You can never say that it definitely didn't happen. Okay, existence theorems never disprove something happened. They can just say maybe it did, but we don't know. Okay, take a look at number 2. Okay, this time we're talking about a bank account. Okay, it says, does IVT, that's intermediate value theorem, guarantee that your bank account was equal to $400 for some day between September 1 and September 10? Okay, what was your bank account's amount on September 1st? What was it on September 10th? 500. Then did it have to hit 400? Okay, correct answer is no. Why not? Bank accounts aren't continuous. You don't have to go cent by cent. If I deposit $50, my bank account goes from 300 to 350 and it doesn't hit all the numbers in the middle. Does that make sense? So go ahead and write down that your part 1, thank you. You're looking to see if the bank account is continuous. You would say no, it's not. Okay, bank account not continuous. Therefore, IVT cannot guarantee this. Now, look at your part B. It says, is it possible that your bank account hit 400? Yes, but can I promise you that it hit that number? No. Okay, so I'm gonna put here, yes. IVT doesn't guarantee it. But it is possible. Okay, or like we put on the last question, it could have happened. We just can't promise that it happened. Okay, contrapositively, we can't promise that it did not happen either. All we can say is we don't know if IVT doesn't. Make sense? Okay. We're gonna do one more. Let's do number 3. Okay. So number 3, we have a function x cubed plus 1. It says, does IVT guarantee that f of x has a root on the interval from -2 to 2? So first question, think about this equation. Is that graph going to be continuous? Yeah, x cubed is like a little squiggle, okay? But pretty much all of your polynomials are going to be continuous. So I'm going to put step number 1, continuous, check. Step number 2, I'm going to find my starting y value and my ending y value. My interval is from -2 to 2. So I'm going to find f of -2 and then f of +2. I want to know what my starting y value is, and then I want to know what my ending y value is. And the way that I'm going to find those is I'm just going to plug them in. So let's start off with x cubed plus 1 plugging in a -2. What is -2 cubed plus 1? So -2 cubed would be -8, plus 1 would be -7. Very good. Okay, now let's find our ending value. This is the starting y value. Now we need to know the ending y value. Now I'm plugging in a 2. So now I'm going to have 2 cubed plus 1. 2 times 2 times 2 is still 8, plus 1 is 9. So I start at -7, I'm ending at 9. These have to be different numbers, are they? Yes. Step number 3 is the number I want has to be where? In between. Doesn't have to be perfectly in the middle, just somewhere in the middle or somewhere in between. So if I want a root, what number would I be looking for? Very good. Okay, a root when it comes to polynomials is an x-intercept. or it is also sometimes called a zero. So the number that I want, if I want a root, is a zero. Is zero between those two? Yes. So then in step 3, you would say 0 is between -7 and 9, therefore. I can guarantee that for some value, I'm going to get 0 as the y. So there must exist an x equals c within. Now, where does my x value have to be between? My x. -2 and 2. So that my y value can equal 0. Okay, and it is a little bit confusing, but your x has to stay between your x's, just like the y value that you want has to stay between your y's. So x stays between the x's, y stays between the y's. Does that kind of make sense? Okay. We're going to do one more theorem, and then I'm going to give you a little bit of time to try those questions on your homework. So go back to your pink sheet. We're going to do squeeze theorem. Okay, for squeeze theorem, you need 3 continuous functions. Okay, we're going to call them f, g, and h. And your f function is pretty much always going to be between the other two. So if your f is sandwiched between a g and an h, it's probably squeeze theorem. Now, here's what it says. If g's limit is L and h's limit is L, then f's limit would have to also be L. Let me show you what I mean by that. Okay, let's say that we have a graph. And let's say that this is my f of it, or my h of x. And let's say that this is my g of x. Now, as I get closer and closer to x approach a, both of those graphs, so we'll say this is x equals a, both of those values are coming off to whatever L is. Okay, we're doing L for our limit. So as h gets closer and closer to a, my y values get closer to L. And then the same thing with my g function, that as my x's get closer to a on both sides, my y value is getting closer to L. Okay, if I want to construct a third function that always stays greater than or equal to g, but less than or equal to h, then essentially what happens is your f gets kind of squeezed in the middle, that it has to basically equal the same thing. Okay? Your f would basically get pinched so that if these two have the same limit, then the only way that f can continue to be between them is if it's also that exact same number. Okay, so over here to the side for your steps. You're going to make sure that all of your functions are continuous. Okay, and remember that it also has to be true that your g is less than f less than h. Okay, basically all that means is they're telling you f has to be between g and h. So if those two conditions are met, then you're going to find your limit for the first one and the second one and make sure that they come out equal. So we're going to find the limit as x approaches a on g of x. And the limit as x approaches a on h of x. If they come out the same, then I know what f would have had to be. If they are the same, then we know LIM x approach a on f equals the same thing. Okay. So all your graphs have to be continuous. F is in the middle. Find G, find H. If they match, then you know F had to be the same thing. Okay, go ahead and look in your packet for me, please. at question number 7. Question number 7. Anybody need more time on this? Go ahead. All right, so it says right here, this is 100% gonna be squeeze theorem pretty much anytime that it says this. Okay, that my F gets squeezed between G and H, and it says what would have to be the limit of F as X approaches 6. Then the first thing that I would do is check if they're continuous. Now, you know what the graphs of sine and cosine look like. Are they connected and continuous? Okay, yes, kind of like polynomials. Okay, sine does this, cosine does this too, so they're both continuous. Okay, so I'm gonna put step number 1, are they continuous? Check. Okay, we know what sine and cosine look like, we know that they don't have any issues. Step number 2 is I'm gonna find the limit as x approaches pi over 6 for my g of x. Then I'm gonna find the same limit as x approaches pi over 6 on each of x. Now, one thing I want to point out, why do I have to use G and H to find F? They didn't give me the equation for F. Yeah, I know F is between, but they're not like giving me something to plug into. So I'm having to use G and H to determine what I would know about F. All right, let's plug into G first. I have 4 sine x, so now it's 4 sine pi over 6. Okay, pi over 6 is which finger? Pi 6 is this one. How many fingers below for sine? So it's 1/2, and then it's 1/2 times 4. What is half of 4? 2. Now we're going to go to our H equation. We're going to plug in our pi 6. So it's 2 cosine, I'm reading from right here. 2 cosine pi 6 minus pi 6. What's going to happen when I do pi 6 minus pi 6? 2 cosine 0. And then remember, 0 is your pinky, but your cosine fingers are up. And so if all of them are up, that's root 4 over 2, which is 2 over 2, which is 1. So I'm going to have 2 times 1, which is also 2. The only way for F to have a limit between 2 and 2 is for it to also be 2. Make sense? Okay. Now, come back up to number 6, and I want to talk about number 6 for a second. So first thing that you should notice on number 6 is that they put this. Anytime they put this, it's squeeze theorem. So what I want you to do is find the limits for G and H as x approaches what number for number 6? X is approaching 4. So we're going to find x approach 4 on this one. And then we're going to find x approach 4 on this one. Okay, and then very quickly, we're going to realize that we end up with a problem. When I try to plug in my 4 to the top, 4 squared is minus 16 is 0. And if you do the same thing on the bottom, you're going to get 0 over 0. What do we do when we get 0 over 0? Okay, do more. Very good. So how can I factor the top here? So we're basically going to have to fix these limits before we can evaluate them. Okay, very good. X plus 4x minus 4. And then on the bottom, I'm looking for a way to factor negative 8x plus 32. What could I do? Okay, pull the negative 8 out. What would be left? X minus 4. And remember, the whole point of factor cancel is now that I cross these boys out, okay, I can retry the limit as x approaches 4 and find my answer. So if x is approaching 4 here, that would be 4 plus 4 on top, which is how many? 8, and then divide that by -8, I get -1. So G's limit is -1. Let's now do F's limit. Okay, same thing's gonna happen. You're gonna get 0 over 0. How can I factor the top of that one? Okay, great. So it's gonna be your ABC. So I need numbers that multiply to 4 and then add to -5. That's right. So I'm gonna pick X minus 1 and X minus 4 over, I already had an X minus 4 on bottom. Cross these boys out. Only thing that's left is my X minus 1. And now that those terms are gone, I'm not going to get 0 over 0 anymore. I'm going to get an answer. Okay, let's plug it in. LIM, X approach 4. Whoop. 4 minus 1 gives me what? 3. Okay, now you have to read your question carefully. If I know that F always stays between these two functions, which of those answer choices could be a possible value of the limit? Okay, it would have to be 1. It could be. Okay, but which one must be? Okay, add in a part E, cannot determine. Okay, the only way that you know the answer is if they come out the same. So if I get -1 and 3, I know it's somewhere between there, but I can't tell you the number unless they both match each other. So if they were both 3, I would know the answer is 3. But if they come out to be a range of numbers, it could be any number in the middle, essentially. Does that make sense? Okay, so pull out your Chromebooks. We're gonna do maybe 2 together on IVT and squeeze theorem. Okay, but then we do still need to finish the last 2 theorems after that. So pull your Chromebooks out. Aaliyah, this is for you. Yeah. Huh? I have it. So I should have made it his weight, you know. Should have done it. All right, so you're looking for your homework on theorems. Should say quarter 2, but oh well. And then these are kind of weird at first. So we can do 2 of them if we have to. But kind of look at it first and then we'll go over it. Okay. So it says you have a function. Okay, does it tell you it's continuous? Read in the paragraph. Because we're missing a big chunk of it, so we don't know it's continuous unless it says it. Does it tell you it's continuous? Yes or no? No. Then in the first drop-down menu, you're gonna say, since the function is not necessarily continuous. Now, this is important. Could it be continuous? Yes. So don't pick that it's not, because you don't know. If it tells me it's continuous, I know it is. But if it doesn't tell me, I don't know. It's not necessarily continuous. Okay, then intermediate value theorem does not apply or cannot be applied. Sorry, mine is tiny. Okay, so that's what you should have first, is that they didn't tell me it's continuous, so I cannot apply intermediate value theorem. Okay, therefore, next drop-down menu. There may not exist. Remember, we can't tell you it doesn't. We just know that it might not if IVT doesn't promise it. Okay, and then C, look at where it is right here. C is an X value, and X values have to be between other X values. So in your question, what are the X's of the interval from what 2 numbers? -4 until 3. So x's have to stay between x's. We're talking about the interval from -4 till 3. Okay. Once you have that, go into question number 2. Everybody good with that? May I take it off? Not yet, okay. All right, for the next question, I want you to read it and see if it tells you it's continuous. Okay, when you're in question number 2, tell me whether or not it says it's continuous, and then look at your drop-down menus. Are we good now? All right, so second question, does it tell me it's continuous, yes or no? Okay, right there, it says it's continuous, then I know that I can use intermediate value theorem on it. So I'm gonna put it is continuous, so intermediate value can be applied. Intermediate value theorem can be applied. Now, it states that for any k on the interval, look back at your pink sheet, is k the x or the y? K is the y, then k has to stay between the y values. So let's look at my graph. For the part that's missing, I need to stay between this y value and this y value for intermediate value theorem to guarantee it's going to happen. What is this y value? 2, and what's this y value? 5. So then my k would have to be between 2 and 5 for me to promise that it's going to happen. Okay, then it says there exists a value c. Look on your pink sheet. Is c an x or a y? C is an x, then it has to stay between the x's. And what are the x's of the missing chunk of my graph? -2 to 3. So it's going to be -2 to 3 here. So that I can promise that f of c is going to equal whatever that k value is. Now go down to the last part. It says, what about 0? Can I promise that 0 is going to happen? Well, then think to yourself, is 0, that's my k, between these two numbers? If I have to stay between 2 and 5, and they pick 0 as my y value, does IVT promise that number will happen? No. So you're going to come right here and say, there may not exist. Remember, IVT never tells you it doesn't happen. It just says maybe, maybe not. Or it could say yes for sure, but it'll never tell you there's definitely not. Does that make sense? Okay. Then I feel like the squeeze theorem ones are pretty self-explanatory. So I'm going to give you like maybe 15 minutes. Work through some of them. You might get a few wrong, but just raise your hand, help each other, and then we'll do the last part of it. That's okay. Is this the first one? Okay, so go up. Does it say if it's continuous? Okay, so it can be applied. Okay, then your k value is a y value, so it has to stay between the y's. What are your y values here? Okay, now make sure 5 to 3. A smaller number has to go. So your k has to stay between 3 and 5, and your c has to stay between X and whichever. I think I touched it.
Cause you did say.
Yes. Did you put 5-3 instead of 3-5?
Wait, what number?
Okay, then you
I got
want 4. What's that?
No, when I was first.
Yeah, so then you say there has to be,
Yeah.
there definitely is. Okay, does that make sense?
You did not.
Y'all make sure on the next one, you know how it has to be between 5 and 3? Make sure you put them 3 to 5. You always want the smaller number to come first, the bigger number to come second.
You said mine.
Yes, I will.
There may not. Wait. You said mine too.
Yes. But I might need you to all tell me again who I'm resetting. Okay, hold on.
Wait, no. It exists. I told. You're also resets nine.
Yeah. Yes. Okay. Okay, we got about 30 seconds and then we're gonna go on to the next 2 theorems. Would you mind please? Okay. You done? Yes. Okay. Then make sure -5 to 0, since K is a Y value, those need to be your Y values. So how low does this leave off? That's not 0. What Y value is that? What's the highest point? Now, it also says it up here. See how your Y values are 5 and -2, so you'll put -2 and 5. And then the numbers that you're listing need to go for the X's. See, I think you just had them backwards, yeah. So then your X is -5 on the left and 0, correct? Okay, then they're picking a Y value of 1. So is 1 between these for your K value? Yes, so then you would say there does exist. Okay. All right, last 2 theorems. Okay, what is different? So look at the other side of your pink sheet. Okay, let's put Chromebooks away just for a minute while we cover these last 2. Okay, what is a different condition that on the front, they only had to be continuous, but now that we're going to the back, what does it say? Continuous and what? Differentiable. So remember that continuous means they have to be connected. Differentiable means no cusps, no corners, or vertical tangents. Now, remember that usually we would also say you can't have any discontinuities, but because they're saying it has to be continuous, I'm not going to list that as well. So it has to be connected, can't have any cusps, corners, blah, blah, blah. Okay, if that's true, then whatever your f of b minus f of a is, your derivative has to equal that at some point. Let's draw a picture. Okay, draw yourself a little graph, kind of like that. Let's say that this is my A, and this is my B. Now, you guys have seen this before. This is the formula for slope. F of B minus F of A tells you the average slope from here to here. So I want you to connect those dots just like this. And then I want you to label that as F of B minus F of A over B minus A. That is the average slope. What this theorem says is that if you have a function that's continuous and differentiable, whatever this average slope comes out to be, there has to be a place where the derivative is exactly equal to that average steepness. Okay, so what this means is I'm gonna kind of estimate where it happens, but that maybe about right here, okay, that my f prime of c, or my instantaneous rate of change, instantaneous slope, is equal to that exact same value. So whatever your average steepness is, your derivative has to equal that somewhere on that interval. Let's write your steps, then let's do an example. Okay, step number 1 is that you're gonna check that it's continuous and differentiable. Okay, I'm gonna put a little check there. It has to be both, not just continuous, but also differentiable. Okay, keep in mind that polynomials are gonna be both anyways. Okay, step number 2 is you're gonna find the average rate of change, which is f of b minus f of a over b minus a. This is literally the slope formula. That's y2 minus y1 over x2 minus x1. Then, whatever value this comes out to be, let's say it comes out to be 5, then you can promise me that the derivative needs to equal that number. Okay, so I'm gonna put for step 3, you're gonna set f prime of x equal to whatever that a rock is. Okay. All right, so let's do an example. Okay, go back to your white packet. And we're gonna do example 9. So if you'll turn to number 9, it should look like this. Okay. So first question I would ask you is this function 2x cubed minus 3, is it continuous and differentiable if it's a polynomial? Okay, yes. Okay, nothing crazy is gonna happen on that. Step 2 is we're gonna find the average rate of change, which is f of b minus f of a over b minus a. Now, keep in mind that if they're giving me the interval from 0 to 2, that means that 0 is my a and b is my 2. So I'm going to make that f of 2 minus f of 0 over 2 minus 0. Okay. Then the reason I had you get out calculators is because this one's not really that hard, but on your homework, some of them are long and I don't want to plug in a bunch of numbers. So in the calculator, just go into y equals, and we're going to type in 2x3 minus 3. Oops, not there, in the y equals, sorry. 2x3 minus 3. And then I'm going to go into my table and just kind of pull the y values out to be a little bit lazy, okay? So second graph, and I'm looking for f of 2. So 2's partner is what number? Okay, 13 minus f of 0 will be whatever 0's partner is. What's 0's partner? -3. And then over 2 minus 0. Now, if I have 13 minus -3, what is that the same as? 13 plus 3, which is 16 over 2 minus 0 is 2. 16 divided by 2 is 8. Here's what that means. My average steepness is 8. Then mean value theorem promises me that there will be a place where the slope is 8. Okay, so let's go down to part B. Does mean value theorem guarantee that my f prime has to equal that average rate of change, which was 8? Okay, the answer would be yes. Okay, because remember, my function's continuous and it's differentiable. So IVT guarantees this. There must exist an x equals c within the interval from 0 to 2, such that f prime of c is 8. Okay, IVT guarantees there must be a c between x's, stay between the x's, so 0 and 2, so that my derivative has to equal 8. Then, if it asks you to find it, look right here, it says find the value of c. Then you're just gonna follow step 3, which is to take the derivative and then set it equal to the number that you want. So what is the derivative of that equation? And then we're gonna set it equal to 8. Okay, 6x squared equal to 8. So in this step, we're setting f prime of x equal to the a answer that we got before. Okay, what would I do first to solve that? Divide the 6. Okay, 8 divided by 6 is gonna be 4/3. Okay, but we learned last class, if you leave it as 8/6, that's fine, that's not wrong. Okay, then take the square root. How many answers is this gonna generate? Okay, plus or minus square root 4/3. Now, remember what we said about the x. Your x has to stay between the interval. What was my interval between what two numbers? 0 and 2. So are both of these also within that interval? No, not the negative one, right? So I'm gonna put then my c can only be the positive root 4/3. Okay, the reason that we exclude the negative root 4/3 is because it's not between 0 and 2, and that's part of the theorem, is the x that you get has to stay between the x's of your interval. Okay? All right, let's do one more like that, then we'll do maybe an example off the homework. Take a look at number 10. Okay, it says a car is traveling on a road, here's its velocity. Okay, part A, find the average rate of change. Remember, that's slope. So we're gonna put f of b. Remember, this is my A, this is my B. So f of 20 minus f of 8 over 20 minus 8. Okay, we're wanting to use our graph for this one, so we don't need the calculator. Okay, 20 would be here. How tall is that? Okay, 10 minus 8 would be up here. How tall is that? 20. And then over 20 minus 8. 10 take away 20, how many on top? Negative 10 over 20 minus 8 is 12. Now, if you want to reduce that all the way, you can. I'm just going to leave it. Okay, find the average rate of change. It's negative 10 over 12. Okay, mean value theorem promises that if my function's continuous and differentiable, this exact slope has to happen. So look at part B. Does mean value theorem guarantee that there's a place where v prime, because this is v instead of f, is equal to that number? Yes or no? Okay, if my graph is continuous and differentiable, then mean value theorem will promise that. Is it? Is it continuous? Is it differentiable? No. What makes it not differentiable on the graph? Remember, corners are not differentiable. So for part B, we're going to put no, MVT does not apply if graph isn't differentiable. And there is a corner. Okay, remember that your graph has to be continuous and differentiable. Otherwise, mean value theorem is not an option. Okay, last theorem. Okay, go to roles on your pink sheet. Okay, Rolle's theorem is basically mean value theorem again. Okay, it's a particular example of mean value theorem. Okay, except for that it's when your y values are the same. So notice it's still continuous. It still has to be differentiable, but I'm guaranteeing this time that the derivative has to equal 0 specifically. Now, I want to tell you why that happens. The derivative is going to have to equal 0 specifically because if my y values are the same, what will my f of b minus f of a over b minus a come out to be if they're the same number? 0. That's why it has to equal 0. So let's draw a picture, then we'll do an example. Draw me the exact same picture you did last time, but I need you this time to pick your a and your b so that the y values come out to match each other. So I'm going to pick my a to be here, and then I'm going to pick my b to be over here. So that now my f of a and my f of b are identical values. When I calculate the slope between these 2 points, it's going to come out to be a 0 slope, which means that there has to be another slope of 0 somewhere in between them. And remember, your 0 slopes are like the flat spots on the graph. So this would be your f prime of c equals 0. Now, one other thing I want to point out, is there another flat spot on this graph over here? But I can't pick it because it's not between what 2 numbers, a and b. So make sure the x values you pick for your c have to always be within the interval. Okay, so step number 1 has to be continuous and differentiable. And instead of finding the a rock, you're just going to check and see if the y values match. If they match, what do I know my a rock is? It's going to be a 0 slope. Then I'm going to set the derivative equal to 0. Okay, and then I'm going to put a little note here. Then automatically a rock is 0. So basically, you're just identifying, well, if my y values are the same, I'm not going to find it. I just know it's 0, and then I skip to the last step. Okay? So let's do 1 off your notes, and then, well, thankfully, we're done. Let's do number 11. Can you type that into your calculator for me, please? Okay, we could find these by hand, but we just don't want to. So y equals 2x squared minus 4x. Then I'm going to go into my table and I'm going to look up the y values for 0 and 2. What is the y value for 0? Okay, it is 0. And what is the y value for 2? Also 0. Because those match each other, I automatically know that my average rate of change is going to also be 0. Now, it doesn't matter that they're 0. It just matters that they match. They could both be 6, both be 10. So then in the next step, it says find the value of c. I'm going to take the derivative and set it equal to 0. What is the derivative of 2x squared minus 4x? 4x minus 4 equals 0. And then just blah, 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 solve it. So add the 4 across, 4x is 4. Divide the 4 across, x equals what? 1. Now, is 1 also on the interval from 0 to 2? Because if it's not, you can't use it. Yes, it is. Okay, so let's do one of the MVTs off your homework. Okay, and then you probably need scratch paper for this, so I'll bring it around if you want it. Okay, pull up the first mean value theorem. Okay, and then go ahead and find the average rate of change. Remember, it's f of b minus f of a. Use your calculator. Can you paper? All right, so the first mean value theorem is this one. Okay, so I'm gonna go ahead and type that into my calculator if you haven't already. And then I'm gonna find f of 3 minus f of -2 over 3 minus -2. Remember, that's your formula for A-Rock, and that tells me whatever the magic number is that the derivative has to equal. Okay? So type it in, and then we're looking for f of 3 and f of -2. Okay, so I just typed it in. Has anyone found f of 3 yet? Oh, f of -2 is -30. What about f of 3? 5. And then f of -2 we said is -30. And then over 3 minus -2. Now remember, your minus negatives, those are going to switch to pluses. So it's going to be 5 plus 30 is 35. 3 plus 2 is going to be 5. What is 35 divided by 5? 7. That means that the average slope is 7. Now come over here to your graph. And I want you to place dots at -2 and at, what was my other x? 3. So 3 would be here. Okay, the line that you just drew has a slope of 7. So now it's saying find the value of c where the slope comes out to be 7. Then I'm going to take the derivative and set it equal to that number. So think about your equation. I'm going to put mine back up on the board. What would the derivative of that be? Taking the derivative of this right here. Okay, hold on. 3x squared minus 14x, then what? Plus 7. That's the derivative, and I want to set it equal to the average slope, 7. Okay, so once you find the A-Rock, remember on your pink sheet, the next step, look right here, is to set the derivative equal to that number. So I'm going to minus that 7 across. I have 3x squared minus 14x, and then cross out equals 0. Okay, we are still going to solve this by factoring. What do both of those terms have? An x. Then I'd have a 3x minus 14 left over. Okay, from here, remember, an x on the outside means that x equals 0 is your first answer. And then if I let 3x minus 14 equal 0, how would I get rid of the minus 14? I'd turn it to a plus 14 and then divide by 3. So it'll be 14/3. Now, in your calculator, I need to make sure that both of these numbers are on my interval from -2 to 3. So let's see what 14 divided by 3 actually is. 14 divided by 3 is the same as 4.666. Repeating. So if these are my two x values, will I choose both of them? Which one is not between -2 and 3? This one. So I'm only going to include 0. So this is not on the interval -2 to 3. Okay, so you will only type in 0 as that value. Now, do be a little bit careful. Don't try to just estimate the y value on the graph. they're too zoomed out for you to guess. Use the calculator for the Y values. So even though this one, it was perfectly -30 and then perfectly 5, most of them, they're not pretty numbers like that. That's why you have your. Okay. Do you want to do a rolls or are you done? You want to do it? All right, let's do, I think the very last two are rolls. Let's do the very last one. Okay, so we have our equation. Go ahead and type it in. And then we're interested in finding the Y values at -6 and at 2. Okay, X equals -6 to X equals 2. So let's find those. -16. All right, so I'm pulling up my chart. -6, what's my Y value? 20. And what about at 2? 20. Now remember, if these come out to be the same, automatically, what's my slope formula between 2 points of the same height? 0. Then I'm going to take the derivative, set it equal to 0. So set f prime of x equal to 0. But remember, the reason I can skip to equal 0 is because if the points are the same height, the slope between them automatically has to be a 0. Now, what is the equation of my line? Yeah, but make sure we take the derivative. Yes, 3x squared plus 14x. What happens to the 16 if it's a derivative goes to 0 and then equals 0. Okay, and ooh, almost the same question. Okay, we're gonna pull our x out. I'll have a 3x plus 14 this time. What will the x on the outside give me as an answer? 0. And then what will the 3x plus 14 give me? It'll be a -14 and then divide the 3. Now, if 14 over 3 was 4.6, -14 over 3 is going to be -4.6. Okay, now remember, this is a different interval. So if I want to stay between -6 and 2, am I going to still eliminate this one like I did last time? No, I'm going to keep it because this is between -6 and 2. So for your answer, make sure you click first. -6 is here. 2 is here. And then I can see that I have a flat average rate of change. Okay, then I'm going to come down here and type in my answers. It was 0 and -14 over 3. Now, can I just make you nerd out like for 1 second? Where are the flat spots on the graph? One of them is at 0. And where's the other one at? -4.5. So for the zeros, you can see the flat spots. Okay, versus like a slope of 7 is a little bit harder to see. Okay, you get it? All right, good job.